Let's do some homework problems from section 1.6, part A. Simplify the following expressions. Number 2, 7x minus 5x. These are like terms or similar terms because the terms, separated by a plus sign, both have the same variable. 7x's and negative 5x's is 2x's. Or of course you could think of this as 7x's, take away 5x's. As long as you're working with the same type of thing. Question number 8 says 7a plus 3b plus 6c. This expression cannot be simplified. The terms here cannot be combined. Here I have 7 A's. In another pile I have 3 B's. In a third pile I have 6 C's. But they're all different kinds of things. It's like saying I have 7 apples, 3 bananas, and 6 coconuts. Sure, I can throw them all into a big pile, but that's not going to change the kind of fruit that I have. I'll still have 7 apples, 3 bananas, and 6 coconuts. I can either rewrite this problem, circle it as my final answer, or say, already simplified. Question number 10. Five x plus 6 minus 3x. In this case, some of my terms are similar and others are not. Here I have some x's, here I have just some 1's, and here I have some more x's. The total number of x's that I have in the two piles when I combine them into one big pile is 2x. The 6 1's, there's nothing I can do with that, it's just plus 6. This is my final answer. Number 12. 6a plus 7b plus 8 minus 3b. Again, I have some terms that are like each other and others that are not. I have some a's, some b's, some 1's, and some more b's. So the two terms with b's in them can be combined. 7b's and negative 3b's is 4b's. Now that I've found the ones that I can combine, I can write the plus 6a plus 8 at the end. Or if I wanted to, I could leave the terms in alphabetical order, writing 6a plus 4b plus 8. We have a convention in algebra that says that your terms should be in alphabetical order or descending order of power, but we'll talk about that later. And if you have a constant term, a term with no variable attached to it, it should come at the end. This is not a hard and fast rule. Both of these would be considered correct. But it'll help you as you progress. When we learn how to combine even longer expressions with each other, it helps if they're in alphabetical order, because then you can easily see what the like terms are in each expression. Question number 14. Six x plus 5 minus 2x plus 3 minus 4x. Here I have some x's, some more x's, and some more x's. And here I have some 1's and some more 1's. If I use the rule that the terms in my answer should be in alphabetical order with constants at the end, then I should put my x's first. It looks like I have 6 x's in this pile, and then I spend 2 of them, or take 2 away. That would leave me with 4 x's. At the very end, I take an additional 4 away, which would leave me with no x's. I can write 0x as my term with x in it. For my ones, I have 5 and 3. Plus 5 plus 3 is 8. So technically, I can write this answer this way. It's not incorrect. I would accept it on an exam. WAMAP may or may not accept it. 0x is 0 because 0 times anything is 0. So this technically isn't simplified as much as it can be. 0 plus 8 is 8. Question number 20. 8 minus 0.75x minus 15 minus 2.30x. I have some constants and I have some x's. Let's work with the x's first so that that term comes first in my answer. I've been taking a shortcut in this video, but remember what we're actually doing here is reordering the terms using the commutative property of addition. So if I start by reordering the terms, it's maybe easier to see that the x's go together and the constants go together. How many x's do I actually have? It looks like I'm starting out in debt, 0.75 of an x. I'm already down 0.75 of an x. And then I spend 2.30 more x's. If I'm already in the hole and I spend even more, I'm going to be further in the hole. This piece here is going to be negative. How far in the hole? When adding 2 negative numbers together, you add the numbers and the sign is negative. 2.30 and 0.75 is 3.05. That's how many x's I'm in the hole. If I have $8 in my bank account and I withdraw 15, then I'm overdrawn, I'm in the hole, $7. This is my final answer. In this problem, the numbers in front of the variable were decimals. That doesn't really make any difference. The numbers in front of the variable can be decimals, fractions, or whole numbers. So far, we've really only worked with whole numbers, but they can be any kind of number. The process is the same, and that's important in mathematics. Make sure you understand how to do a type of problem by doing a simple problem, one with just whole numbers in it. But then be prepared to apply the process you learned to problems with decimals or fractions instead of whole numbers.